Okay, so today we're going to look at logarithmic functions. That is where we are going to start. There'll be two logarithm units, okay, but we got to get the basics first. Now, this is a non-calculator section, so we're not going to use a calculator through any of this unit, okay? It's all going to be mental math. The biggest part is to understand the properties, because those are going to help you once we do get to the next unit, and you are allowed to use calculators. You still need to know the properties first, otherwise, in order to manipulate them, so you can put them into the calculator. So we're going to look at them without calculators first, and then in the next unit we'll look at them with calculators. So exponential form is something that you should be pretty familiar with. Okay, b raised to the x is equal to a, where b here is going to be our base. Okay, x of course is our exponent, hence the word exponential form. Okay, that's our exponent, and a is what we call an argument. Okay, and a here is going to be that argument. So, when you're talking about exponential form, okay, you have some base raised to an exponent, and that's equal to some answer or argument or whatever you want to call it. Now, logarithmic form, okay, it's going to look something similar to this, only we obviously are going to have a logarithm in it. So, log, our base comes down here, so log base b, okay, of a is equal to x. Okay, the whole purpose of logarithms is to look at the exponent. That's what the logarithms are used for. Okay, so we can look at the exponent instead of all the rest of the stuff. So logarithms will always be equal to their exponent. So this is still my exponent. B is still my base. Okay, and a is still going to be an argument, okay, answer, whatever you want to call it. So, when we are looking at these, write the following in exponential notation. So, they're going to want me to take a logarithm and write it as an exponent. Okay, so it's just a matter of switching back and forth between those two forms on the top. So, if I have this right here, well, this is my base. So, it's going to be 5, okay. This is my exponent raised to the second power is equal to that argument, so 25. And I'm doing the little circle here. A lot of people might remember it from their Algebra 2 class, that when we look at logarithms, you go in this circular type pattern, okay? So you start here at the base. You always start at the base, and then we're going to loop around, so 5 squared equals 25. And it makes this cute little snail-looking thing, okay? Not everybody sees the snail, but that's what it... That might help you remember it. It makes this cute little snail with his little snail shell here, okay? So, that's what we're kind of looking at. And this thing right here should make sense. 5 squared equals 25. Well, that's true. If you got like 5 to the 25th power equals 2, that's obviously not correct. So, be very careful with these. Make sure that they make sense to you. Okay, so same thing here. 2 raised to the 1/2 power is equal to the square root of 2. If you remember back to our exponential units, okay, that is very true. If I have a 1/2, that means square root. If I had a 1/3, that means cubed root. That's what those things mean. So 2 to the 1/2 is the same thing as the square root of 2, and that is very true. So if you want to hit the pause button and see if you can do this log real quick, you might even be able to do it without hitting pause. These things are really short. Okay, I'm going to go ahead and do it. So we get 6 raised to the -1, going in that loop, is equal to 1/6. Okay, not just the 1, but this whole thing here, that whole 1/6. So 6 to the -1 equals 1/6, which hopefully makes sense. I'm just kind of throwing in some of our old exponential rules. If I had a to the 1 to the -1, that's the same thing as saying 1 over a to the first power. Okay, because we're going to use these exponential rules when we start solving. So if I have a negative exponent, it drops it to the bottom. If I have a fraction exponent, a to the 1/2, okay, then it's going to become a square root, or a to the 1/3 would be the cubed root. You don't necessarily have to write those down in the notes. I'm just kind of writing them to remind you. So a to the 1/3 is the cubed root of a. That's what those things mean. Okay, now going the other direction, write the following in logarithmic notation. So now we want to change it to a log. Okay, so here we're going to go from the exponential to the logarithmic. So this right here is my base, and that's where I'm going to start. And then we're going to do a nice little loop again. Okay, I don't know if this is a snail inside his shell still. Okay, but it's log base 9 of 729 equal to 3. Okay, you should be able to loop. If for some reason you try to do your loop and then one of those numbers isn't in it, so say I go 9, log base 9 equals 3, well then I'm stuck. Okay, then I'm just circling here. You got to be able to include everything in that loop. So base 9, start there, 729 is equal to 3. So same thing here, log, this is my base 5, okay, of the cubed root of 5 is equal to the exponent. Logs are equal to their exponents always. So equal to 1/3. So that's how you do your conversions. Again, you can hit pause if you need to, or you can just try to do it while you listen to me ramble, which is kind of what I'm doing now. Okay, you should probably have that done by now, so here we go. Log base 6 of 136 equal to -2. Be very careful when you're writing your bases on these logs, okay? This base needs to be down. It's a subscript, okay? It needs to be down and a little bit smaller. It definitely needs to, you need to make sure that you can tell that it is a base, so it's way down here, okay? Now, solving for x, we're going to use those conversions in order to solve. So log base 4 of 16 equals x. We don't really know what that means, but if I change this to exponential form, what this says is 4 raised to the x is equal to 16. Now, I said we're not going to use calculators in this unit, so what we're going to do is mental math. 4 raised to what power gives me 16? Okay, simple. 4 squared, right? So x has to be 2. Okay, because if x was 2, then I would have 4 squared, which is equal to 16. That's true. So x is equal to 2, and that's all you're really doing. You're going to convert these. So here I've got 9 raised to the x power is equal to 3. And then I have to figure out, what does x have to be to get from 9 to 3? Okay, well, it obviously can't be a power. It can't be 1, 2, or 3, because then my number is going to get bigger. I'm trying to go from a 9 down to a 3. Okay, if I do negatives, well, it's going to flip it, and I'm going to get fractions, and I don't have fractions. So when I see a whole number, I should be thinking fraction exponents. So for instance here, if x is 1/2, well, that's like saying 9 to the 1/2 power, which is the same as saying the square root of 9, which is equal to 3. So x has to be 1/2. Okay, so that's how we go from larger numbers down to smaller numbers, not counting fractions. Because here on the next one, we're going to see the fraction. So again, we're going to convert. So 4 raised to the x power is equal to 1/4. So now I have to figure out, what does x have to be to get to 1/4? Well, that's simple. I've already got the 4. I just need it on the bottom. Well, how do I get something to drop to the bottom? I use a negative exponent. So x is equal to -1. Okay, going back to what we said before, a to the -1 is 1 over a. So 4 to the -1 is 1 over 4. Okay, if, for instance, just to toss one more out there, let's say I had log base 4 of 1 over 16 equal to x. Well, then I'd get 4 to the x is equal to 1/16. Well, how do I get 1/16? Well, that's simple. Okay, first I got to figure out 4, what do I have to raise 4 to get a 16? Well, I would square it, so x has to be 2. Okay, because 4 squared would give me 16, but I want 1/16. How do I get it to drop to the bottom? I use a negative. So if x is -2, 4 raised to the -2 would be 1 over 16. Okay, so that's how you would go about doing those. Sometimes they're going to move that x around. It won't always be equal to x, so sometimes I might have something like this. No problem. If I use my conversions, it's not going to be a big deal. So 5 raised to the 3rd power is equal to x. Well, what's 5 cubed? It's 125, so x is just 125. And there's nothing more to it than that. Okay, and these are always going to be numbers that you should be relatively familiar with. If not, you can actually write it out, 5 times 5 times 5, and then do 25 times 5, and actually go back to like 3rd grade multiplication. All right, so here again, so I've got x raised to the 3rd power is equal to 27. Okay, well, what raised to the 3rd power is 27? Okay, if you said 9, that'd be a little incorrect. 9 times 9 is 81 times 9, that gets really big. Okay, but 3 cubed would be 3 times 3, which is 9, times another 3, which is 27, so x has to be 3. Okay, you have it on your own. You can hit the pause button, see if you can get it correct. I'm going to keep on going here, so I've got x raised to that second power is equal to 25. So what does x have to be? X must be 5. Okay, because 5 squared is 25. Now, this next part it says properties of logarithms. I typically refer to these as the special properties of logarithms, because we're also going to have different processes that we do where we have like the products property and the quotient property. So I consider these the special properties. Okay, so the special properties, if b is a real number, okay, our base has to be real, has to be positive, and it can't be equal to 1. The reason why we can't do 1 is because if you think about this is the base, so 1 raised to any exponent is going to be 1. So that's kind of, we would just do circles on this, because 1 raised to any power is still 1. Okay, so that's why we exclude b equaling to 1 is for that purpose. So anything else that is positive and a real number, so no imaginaries, then we have these three properties. Okay, these are just statements. So for instance, this one, log base b of 1 is equal to 0. Okay, so if the argument is 1, okay, that's this right here. If that argument is 1, equals 1, sorry. So if that argument is equal to 1, then the log is equal to 0. Okay, no matter what base. That's what that thing is saying. Okay, that is exactly what that's saying. No matter what base. That's why they just use this generic, oh, I didn't write it so you could see it. That's what this generic being means. That means no matter what that base is, as long as it meets these parameters up here, so it's got to be positive and it can't be 1, as long as it meets those, then if the argument is 1, okay, then the answer is 0. Reason. Okay, why is that true? Well, if you think about this, b raised to the 0, okay, well, what is b raised to the 0? Because if I convert that, I get b to the 0. Anything raised to the 0 is going to be 1. Okay, so anything raised to the 0 is going to be 1. So that is the only way to get a 1 is to have a 0 as the exponent. Okay, with the exception of 1 to the 1, but again, we're not using 1. So everything else, so if my base is 2, I have to raise it to 0 to get 1. If my base is 3, I have to raise it to 0 to get 1. Okay, so that's kind of what that looks like. Now, 2. Okay, if my base and my argument are the same, okay, if the base and the argument are the same, then it's going to be equal to the exponent. Okay, so if you look at this right here, if you see log base b of b raised to the x power, okay, well, my base and my argument are the same, so it has to be equal to the exponent. Okay, in this particular case, the exponent is x, which is why it's equal to x. Okay, so that's what that's trying to tell you. And you can see that, okay, you can see that if you convert again, I would get b raised to the x power is equal to b raised to the x power. Well, that's going to be true no matter what b is and no matter what x is. That will always be true. Okay, so this will always hold true. Same thing here. Okay, this is, first of all, this is an exponential form. A lot of people want to say it's logarithmic because there's a log there. Okay, but this is a base raised to an exponent, so this is exponential form. This is log form. It starts with a log. Okay, so this is exponential form. Okay, but the same thing is going to hold. So if my base and the base of the log in an exponent are the same, okay, so these two things here match, then it's going to be equal to that argument in the exponent. So it's going to be equal to that x. So, again, do a little converting, and you can see that that will hold true, because here if I converted, I would go log, this is my base b of x is equal to the exponent. Well, what is the exponent? Log base b of x. It's that whole entire thing up there. So that's going to hold true no matter what b is and no matter what x is, because they're the same thing. Okay, so these are my three special properties is what I call them. Okay, you have to know them. Spend the time, study them, know them, understand them, because they're going to make so much of the stuff a lot easier if you just know them. For instance, on A, instead of trying to square it and then trying to convert it and doing all kinds of stuff like that, if I just know that my base and my argument are the same, it's equal to the exponent. So my answer here is just 2. Okay? The answer there is just 2, and that's based on that second property. Okay, so if you look at that second property right there, log base b of b raised to the x, okay, my base and my argument are the same, that's true, 3 and 3, then it's just equal to the exponent, okay, so that x up there. So my exponent is 2, so this thing is equal to 2. So that's property 2. You don't have to identify the property. I'm just doing it for the sake of your notes so that when you go back you can see which one I was using. Okay, so same thing here, log base 3 of 1. Okay, the fact that I have a 1 right here should immediately set off alarms. Okay, when my argument is 1, then it's equal to 0 no matter what my base is. This could have been a 4, a 5, a 700, a 3,000, as long as it was a positive number. Okay, and then it's going to be equal to 0. So that is the first property. Okay, so that's property number 1. And then here, I have 5 raised to the log base 5 of 3. Okay, I don't know if you can see that. See if I can zoom in a little. There it goes. So 5 log base 5 of 3. Okay, so if I have a base and a base, they both match. Okay, then it's just equal to the argument. So this whole thing is just equal to 3. Okay, pretty simple, pretty easy, pretty quick. Okay, that was the third property. Property number 3. Okay, so if you know these properties, this is super easy. If you don't know those properties, that can be really, really confusing. 5 log base 5 of 3, and it's all in an exponent. That's crazy stuff, but my bases here match, so it's just equal to the exponent. Know the properties. It will make your life easier. It will make this test easier. Alright, so let's look at the on your own. Hit that pause button, try them, make sure you get the correct answer. Shouldn't take very long. Okay, come back, make sure your answers match mine. So here, log base 7 of 7 to the negative 1. Base and argument match. It's equal to the exponent. Special property, that's property 2. Okay, right here on the next one, log base 7 of 1. Okay, my argument is 1, so it's automatically 0. Doesn't matter what that base is, so it's equal to 0. Okay, and that last one, 2 raised to log base 2 of 6. My bases here match, so it's just equal to the argument and the exponent, which is just 6. Okay, super easy, super simple. Hopefully those basics are nice and you can get those down. Okay, just memorize those properties. I can't say that enough. I can't emphasize that enough. If you know those 3 properties, it's going to make things a lot easier on you. All right, good luck.